The figure shows the logo of a music app for a smartphone. The logo is subject to transformation in the following order. So from point P to P1, it goes through central symmetry. From point P1 to P2, the object goes through translation. From P2 to P3 through axial symmetry, and point 3 will end up at point 4 after being rotated clockwise through 90 degrees. So I have the points laid out here on my page as shown, and I have indexed the outside points on my drawing, and each of these points will go through the same translation that the point P will go through. So just look back to where each of these outside points on the drawing I have indexed and given a name. So the completed drawing should look something like this. Okay, we should be able to visualize what our object is going to look like in each of the views, so I'll know if my drawing is correct or incorrect. So starting off with my object here, in this position it goes through central symmetry first from point P to P1. So central symmetry is essentially axial symmetry twice, so it's going to be flipped over and then flipped upwards. So I know that my object, if I'm trying to visualize it, if I can imagine being flipped over and then flipped up, going axial symmetry through axial symmetry twice, my object should look like that. The second part of my drawing from P1 to P2 goes through a translation. So under a translation, my object will move to a new point on the page. And it won't rotate, it won't be flipped over, it's just going to be moved to a new point on the page. So it should be in the same orientation. So a translation from point P to P1. The next part of my drawing, I'm asked axial symmetry from P2 to P3. And this is my line of symmetry here. So basically it's going to be flipped about that line of symmetry. So I should be able to visualize my shape looking something like that. And finally, the last part of my question is a rotation. So from this point here on my drawing, it's being rotated about into the new position up here. So just to give yourself an idea of what the drawing should look like before you complete it, and to know where to position the drawing on the page. So the first part of my question is a central symmetry from P to P1. So under central symmetry, every point moves through the point of symmetry and to the same distance on the opposite side of that point. So if I join points P to P1, so P ends up at point P1 after going through central symmetry. Therefore, the point of symmetry must be halfway along that line. So if I bisect that line with my compass, so taking a distance greater than halfway, and in bisecting that line, I'm going to find the point of symmetry that every point goes through. Here it is. So starting off with point E, I'm going to join point E through the point of symmetry, and using my compass, I'm going to step the same distance on the opposite side of that line. So under central symmetry, point E will end up here, and it's the same for each of the remaining points. I'm going to join them through the point of symmetry and to the same distance on the opposite side of the line of the point. Point B through the point of symmetry, point A through the point of symmetry, point C through the point of symmetry, and point D. And using my compass, I'm going to step the same distance on the opposite side of the line for each point. So from the point of symmetry to A, point A, point of symmetry to point B, point of symmetry to D, and the point of symmetry to C. Now it's extremely important that you index the points as you take them through the views. So this here is going to be my point D1. Here is my point E1. Point A1 and my point C1. So I'm going to join the points up in the exact same order. So on this drawing here, my initial drawing, I had P was joined to D. I'm going to join P to D on my view here. P was also joined to A. I'm going to join P to A in my new view. D to E. B to C. B to A. P to C. And E across as far as A. Just from here to here. Now also I have a section of a circle drawn in there. To locate the center of the circle, I joined P to E and A to D, and where they cross gave me the center for my circle. So I'm going to do the same in this view. I'm going to join A to D. I'm going to join P to E, same as before. And where they cross give me a point here to draw on my arc of the same radius. That's radius 16 for this question as given in the question. So that arc goes from the line BC to the line PC. Taking my center from the line BC around to the line PC. For the second part of my question, I'm told that point P1 ends up at point P2 after a translation. So if I join point P1 to P2 using a purple pen this time, that particular point is after going through a translation. So under a translation, every point moves the same distance and direction. So if I take each of my lines, each of my the same distance and direction from that point. So I'm going to take each parallel line to the line P1, P1, P2 from each of the remaining points. So extend the point parallel to that from point A, from point B, point C, point D, and point D. So each of the points are going that direction, and they're going the same distance as the distance from P1 to P2. So I can set that length on my compass. I can measure it either way, whatever way I prefer. So from distance from point P to P1, step that distance using my compass from along each of the lines. Again, making sure to index my points as I go. This is my new point D, which I'm going to call D2, E2, B2, A2, and C2. Again, joining them up in the same order. E to D, E to P, P to A, and to locate the center for my arc, I'm joining across from D to A again, similar to here, my first drawing. And from P to E, they cross give me a point here. Set the radius on my compass, the same as the first, radius 16. I can draw my arc from the line BC around as far as the line CP. For the third part of my question, the point P2 ends up at P3 after going through axial symmetry. So under axial symmetry, every point moves at 90 degrees to the line of symmetry and to the same distance on the opposite side of the line. So if I join points P2 and P3, my line of symmetry will have to be halfway between points P2 and P3 and 90 degrees to that line. So if I bisect that line, I'll find the line of symmetry. So take a distance greater than halfway on your compass. I'm going to bisect the line P2, P3. That bisecting line is my line of symmetry. So every point will move 90 degrees to that line of symmetry. So using my two set squares, just missed out on that there. I joined points P2 to P3. I bisected the line, and that line of symmetry is every line will be moving in the same distance or the same direction as the line P2, P3. So I'm going to take my lines parallel across. So every point moving 90 degrees to the line of symmetry. And the same distance on the opposite side of the line, from the line of symmetry to the point. So for point A, set my compass on the line of symmetry to the point A, and swing the same distance on the opposite side of the line. For point B, from the line of symmetry to point B, same distance. Point E, point C, point D. Just extend the line B there so that it intersects, and index each of my points in the same order. So my point D3, point C3, point E3, B3, and A3, joining up my points in the exact same order: A to B, A to P, B to C, C to P, D to P, D to E, and E to A from here to here. Join D to A to find the center for my curve. E to P, a point here, and set my radius. And I'm going to draw the line from line PC around to the line CB. So for the final part of my question, I'm told that the point P3 ends up at P4 after being rotated clockwise through 90 degrees. So the rotation is in a clockwise direction. So I know that to get from point P3 to P4, I join them together first in an orange pen. To get from points P3 to P4, it has to be rotated in a clockwise direction. So if that has been rotated clockwise, I know that the point of my compass has to be down this end of the page to give me a clockwise direction. If it was anti-clockwise, it will be up this end of the page somewhere. Okay, so just having a look at our rotations a second. Given that, take this to be the point P3 and this to be the point P4. Okay, and I want it rotated through an angle of 90 degrees. So to find this point of rotation here, to rotate point 3 around to P4 through an angle of 90 degrees, to find this point of rotation, what I'm going to do is I'm going to join. I'm going to join point 3 to point 4, point P3, sorry, to P4. And I will need to measure off an angle of 45 degrees here, and 45 degrees here, in order to get a 90-degree angle inside here, because the three angles in the triangle have to add up to 180 degrees. This is 90. If I take away 90 from 180, I'm left with 90. These two angles are going to be the same, therefore if I divide that by 2, 90 by 2 is 45. So this angle will have to be 45 and this angle will have to be 45. So going through that here on our drawing, I've joined point P3 to P4. Using my protractor, I'm going to measure off an angle of 45 degrees in relation to this line here from the point P3. So counting up my protractor, 10, 20, 30, 40, between 40 and 50 will give me 45. And again, measuring 45 degrees back this way, similar to my triangle here a second ago, to give me this point of rotation in here. So 45 degrees back this way, so putting the center of my protractor on the point P4 and lining up to 0 with the line. I'm going to count 10, 20, 30, 40, 45. And where those two lines cross, give me the point of rotation to rotate point P3 to P4 by 45 degrees. So each of these other points are going to be rotated through an angle of 90 degrees, through this angle in a clockwise direction. And this is my point of rotation. So the procedure for rotation is, first of all, I join the point I want to rotate back to the point of rotation. In this case, it's point B3 to the point of rotation. I'm going to measure off the required angle, which in this case is 90 degrees. So putting the center of my protractor down on the point of rotation and lining up with the line I've just drawn, I'm going to measure off an angle of 90 degrees. So this line that I've just drawn here, this angle inside here, is 90 degrees in relation to the line B. So to find where that point is going to be, I'm going to put my point of my compass down on this point of rotation, and I'm going to rotate B onto that line. That's going to give me my point B4. That is the point B3 after being rotated 90 degrees in a clockwise direction. I just do the exact same thing for each of the other points. I'm going to use a green pen now for point A. So join from the point of rotation to point A. Measure off an angle of 90 degrees using my protractor. And I'm going to rotate point A onto that line. That's my new point A. Okay, since the angle we're rotating is 90 degrees, I can use my two set squares. If that angle was something like 85 degrees, we would have to measure it using our protractor. But I can draw a line at 90 degrees to another line using my two set squares. So if I join red pen, so I've rotated E, I've rotated B, I'm going to rotate the point E next, join through E, and I can use my two set squares to draw a line at 90 degrees to that. Rotate point E onto that line. Purple pen this time, I'm joining to point C, to the point of rotation. Sorry, blue pen, it's not working very well. Point C to the point of rotation. An angle of 90 degrees in relation to that line. and rotate point C onto that line. And finally point D, again in green pen, join point D to the point of rotation, an angle of 90 degrees in relation to D. And from your point of rotation, the point of the compass down and swing the distance D onto that line. So now I can join up. I have all my points. I can join them up in the exact same order. P to D, P to A to B, B to C, E to D, C to P, and E to A from here to here. And lastly, to find the center of my curve, join A to D, P to E, the center, and set the distance, my radius from the first one, radius 16. Swing it about from